Hey guys, it's Num. I want to explain the map generation system for my procedurally generated game that I'm working on. I turned off the rendering of the top faces of everything so you can easily see how everything is made up of rectangles. When it's actually rendering like normal, you can't tell, but that's how it works. So I created this object called, I just named it a block.java, that uh, does collision detection, and it can be any size. So the collision detection works no matter what the dimensions of the rectangles are. So you can bump against walls. There's no glitching through walls or anything, and everything is made up of these like Lego pieces. So that's just a concept that you need I needed to let you guys know before we get too far into it. So there's basically two main steps to the map generations. First, we're dealing with just a big 2D array of numbers, and then after we get that, that's where it's doing all the thinking and figuring out where to put everything. After we get all that data done, then we're gonna read that data and generate the blocks, like they're called, the 3D objects into the world. So you've only got three different main types of objects. There's zeros, which are these walls. There's ones, which is open space, and then hallways are just basically floors plus ceiling. You see that rooms are always without a ceiling, hallways always have a ceiling. When there's little bridges, these are just, in the code, they're just counted as hallways, they're just twos. Well, I can also show you how it prints out. So the map that we just generated, this is what it looks like before, like after the map generation's done, and before it's created all the blocks in the world. This is what it's got. So it starts out as all zeros, and then it adds in the rooms next, and then after the rooms are there, then it figures out where to put hallways. So it goes zeros first, and it puts all the ones in, and then it puts twos in. So I'm going to be using Microsoft Paint as my visual aid here. We got here 300 by 300, which is the size of the map we're just in. 300 by 300 image. It's all black, which represents zeros here. White is going to be ones. So what it's going to do, it's just going to try to put a bunch of random rectangles on the map, and it's going to try to make sure that when it's putting a new rectangle in the list, that I'm actually using the Java object Java rectangles. So there's a built-in functionality. You can check if it intersects another rectangle. So for every single rectangle on the list, it's going to scan through and make sure that the new rectangle that it's generating at the moment is not overlapping any already existing rectangles. So if I like the new rectangle, let's say I try to generate one here, it's going to say, wait, there's already a rectangle in that spot. You're already touching a rectangle. How about you try to move it somewhere else? So it's going to generate a new X and Y location. It's also going to generate a new width and height until it finds open space. However, if it takes more than 1,000 tries, it's just going to leave it where it is. So near the end, like once all the space is getting filled up, you might have to settle with something overlapping another room, which is fine. Doesn't cause any bugs. It's just if you don't try to fill in all the empty space, then you're just going to get like a big blob of rooms that's just going to be like one big room. So I just told it to cut it off at 1,000 attempts. So after it generates all these rectangles, the next step is to figure out how to connect everything with hallways. So this is the tricky part for the code. So let's use blues to represent twos, because it rhymes. So the way it works, it's going to generate a random X and a random Y anywhere inside the whole map. It's going to say, okay, but it's only going to look at ones. So it's going to say, okay, let's pick this point right here. Now, this is like a seed value. Let me zoom. Actually, let me just pick a spot up here so I can zoom in like this real easily. So it picks that spot. Let's actually, for demonstration, let's pick like this spot right here. You'll see why. Um, so this is like the seed location. We just randomly generated this location. Now what it's going to try to do is if this is a suitable location for a hallway to be branched out from, um, then it will build hallways. But it's so by suitable, I mean, is this location for far? It wants to make. I need to make sure that it's like the surrounding area within 3 units away from it is all empty space. So there's no walls like right next to this spot I found. And I also need to make sure that this spot is located within a room that is isolated. And by isolated, I mean not already connected to another hallway or something. Because I don't want to generate hallways in rooms that already have hallways. Because too many hallways means the maze aspect is eliminated, and I don't want that. I just want to have just enough hallways to have every room connected to the rest of the map, but not just have like hallways everywhere, because that wouldn't be as fun. And now, in order to figure out if this room is isolated, what I do is in all four directions, I scan outward from this point until I find a 0. Using those numbers, it's going to create just like an imaginary rectangle around that. And it's going to scan every single pixel in this border and confirm that they're all zeros in this border. Because if they weren't, that means there's like a hallway already generated. Because if these aren't zeros here, that means there's already a hallway there. If they all are zeros, that means this room must be isolated from the rest of the map. That means this is a room that we want to look at for generating hallways in. So, okay, well, every single direction that makes sense, put a hallway branching out from this point. So let's use like orange, or I'll just use blue again. So it's gonna start building upward. It's gonna say, okay, look straight up, find the wall, and from there, let's just build straight up. We didn't find another room up here. We hit the edge of the map, so don't do anything there. It's gonna also same thing would happen going this way. So no hallways would be built in those two directions. However, going this way, it's gonna say, oh look, we found another spot right here that's not a 0. So we found another room. It's either going to be a 1 or a 2. So it's either going to find another room or it's going to find another hallway to connect to. But it's going to also make sure that this wall is wide enough. It has enough space to fit in an exit for the hallway. So if all these conditions are met, then it's going to just generate a hallway there. Now the reason I moved this over earlier is to demonstrate what would happen. It's going to find this point down here. It's going to say, hey, look, we found another room. But a hallway would actually not end up being generated here, because if this is the center of the hallway that's generated would, it just wouldn't fit in here. It would be like on the corner. So that's what we're trying to avoid there. So we have to make sure that this wall has enough space to fit in the hallway. So if all these conditions are met, this one would end up having a hallway here. If another point is picked here, it would never even try to put any more hallways in this room, because this red border is now not all zeros, because it's going to say, oh wait, over here we got some 2s. As soon as it sees these 2s over here, it's going to be like, nope, let's move on to another random spot. In the code, I'll show you what that actually looks like. So this is a code for generating a random or this is just filling in the list of rectangles with like default 1x1s in the top left corner. Then it's gonna this for loop is gonna go through every rectangle on the list, and this is where it's trying to randomize it and make sure that nothing's overlapping. And once it generates all the random rectangles, then it goes through here. This triple nested for loops will fill every pixel of every rectangle with a value of 1 in the array of numbers. So it's going to look through all these rectangles and fill in the appropriate spots in the map with 1s. Now this is where it tries to generate hallways. So the way it works is I say just call this hallway attempt function like 1,000 times, and I just say, okay, well after 1,000 times, we should have every room connected. It'll take less than 1,000 tries, but I just say go 1,000 times, and we'll be sure that every room will have a hallway at that point. So what this function actually does, just like I said, generate a random x and y, and it's just gonna keep generating random x and y until it finds any spot on the map that's a 1. So this says while we don't have, it says while it's not a 1, keep generating a random spot. So at the end of this loop, we'll have a random spot that happens to be a 1. Now we're going to check, just like I said, we're going to make sure there's no walls within 3 units in any direction. We're also going to check if the spot is contained within a room that is not already connected to a hallway. If both of these conditions are met, then we're going to build hallways outward in every direction that works. So by works, I mean, what I mean is not going to have any awkward hallways being built into corners, and we're not going to have any hallways being built into nothing. We got to make sure there's a room on the other side to connect to, or another hallway, because we can have T intersections also in hallways. I don't really think I need to go over all this code, but if you want to look at this code on your own, this is the code for checking if a room is isolated. It says tell us if the spot is within a room that is not connected to anything else. So it takes in an x and a y, and it'll tell us if it's located in a room that is isolated. So that's that. It's going to return a Boolean. The check hallways, this is once it knows that it's in an isolated room. It has an x, y still. Now it's going to build hallways outward from this location in every direction that works. So we figure out if we need to build upward, it'll do that. If we need to build downward, it'll do that, and left and right. After generating hallways, the only 2 things left to do are removing thin walls and generating pillars. So I don't need to go into too much detail there. Removing thin walls just involves me scanning the nearby adjacent pieces to the left and to the right. If they're both like open space, then I'll know it's a thin wall, and also above and below. Like I need to check both axes. So that's how I do that. For pillars, I just have to check. Pillars are generated whenever there's like a floating ceiling that has like an elbow corner that looks like it's floating there and it needs a support pillar. Then I'll stick one in there. So I just check if it's I look through every single 2 in the entire grid, and I just say, well, if it's ordering 2, a 2, a 1, and 1 in that orientation, or any of the 4 rotations of that, then set that point equal to a 3, if that makes sense. But I don't want to go into too much detail there. So at that point, we'll have our finished number grid. We'll have this. Now, still there's no 3D objects actually in the world yet. So what we're going to do now is read these numbers and figure out where to put the objects. So it goes through every single pixel. So it's going to start in the top left. It's going to move across the entire row, and then it's going to go down a row, then it's going to go across that entire row until it gets to the very bottom right. This line right here just says if the spot we're at has a negative value, then move on to the next spot. You're probably wondering like, well, how we're ever going to have a negative value because we only have 0s, 1s, 2s, and 3s. Well, once it creates an object, I don't want it to be reading any of these spots again. I want it to know which pixels it's already used, so it doesn't like create multiple overlapping objects, because then we can have infinite objects and the game would crash. So the way I fix that problem is just make every pixel that we've used to make it negative. I just subtract 10 from it. Let me go into Paint here. So like I said, we're starting in the top left corner. It's gonna expand a rectangle. It starts, since it knows it started on a 0, so it's gonna expand this it's gonna be like a square to start, it's going to expand it to the right and downward until it contains anything that's not a 0 or whatever it started at. So it's going to get all the way down to like right here, and it's going to say, wait, we found just to the right of us, there's an object there that's not the same type of object that we're already at. So it's going to determine whether this rectangle, there's like two phases to this function. The first phase is to just determine whether this rectangle is wide or tall that we want it to be. So if it figures out that an object is to the right of it here, then we want this rectangle to be tall. So we know we basically are going to expand this downward until we find another object. Then once we do, or until we hit the edge of the map, then it'll know the boundaries of the rectangle for this single object. So it'll end up being all the way down to the end of the map right there. And just to demonstrate, if I actually load this map, we can see that that's actually what it does. It actually does create a giant rectangle for that edge of the map, just like what we thought it would do. Now, the next thing that would happen, after it fills in that giant rectangle and creates that big object, then these numbers are all going to be negative values now. So it's not going to try to do it again for these values. It's going to keep moving to the next one until it gets to here, expand downward and diagonally, until it finds that point where it's touching something else that's not the same type. And then it'll be like, okay, well, we're gonna make this a wide block this time, and let's see how far we can expand it until it hits something else, and it'll stop right there. And the next spot it gets will be this spot right here, all the way probably to the end of the map. So just like that. Now let's run this again just to see if that's what actually happens. This is the big one that we started with, and these are the two that we just figured out on our own. So that's exactly how it worked. The code for that is pretty complicated. So I break it up into two phases when I'm trying to figure out the dimensions of each object. Two while loops. We start out, this is when it's trying to increasing the width and height downward and to the right. This is just a bunch of conditions. It doesn't only check the bottom right corner, it also checks the right edge and the bottom edge to make sure, because we could be like intersecting something. Let's just say, for example, we started like here. Well, once it gets to this point, this single point isn't actually intersecting, but now with our boundaries up here, this right edge is going to be intersecting. So then we know that to stop, we're going to have this rectangle. The width would stop there, and then we'd expand downward, So it has a bunch of if statements in the code to check this checks like the corner, this scans the right edge, and this scans the bottom edge. And then I just assigned this wide block Boolean accordingly, whether it's going to be a tall or wide. And then the second while loop, this comment here says, if we detected a block to the right of our boundaries, then it's gonna. So basically, if this block is gonna be wide or tall, we know to either increase the width or height further. So like I remember when I was drawing, started out with a diagonal line. That was phase 1, and then once we just expand all the way across, that's phase 2, or all the way down, that's phase 2. So it's just going to keep going until it finds either the boundary of the map or any value that's not the starting value. And then finally, once we find our dimensions, we just say what type of block was that, and we say If it was walls, then we create, for each wall there's 3 different objects because we have the lower section, the upper section, or the middle section and the upper section. They're all actual different objects. If it's a open room, we just have one object. We just have the floor. If it's a hallway, we have the floor with the ceiling, and pillars are just single objects also. So I think that's pretty much everything. Hopefully that all made sense. Yeah, if you have any questions, let me know. I know it's super hard to explain this, but hopefully it makes a little bit more sense than it did before. And hopefully you guys enjoy this. I will see you guys soon. Bye bye.